I'm John Valentine. I'm the point of contact both for the CVT and for NA22 in writ large, so across the office. And we have projects in almost all of the portfolios within the NA22 office, or the DNN R&D, excuse me, office. So Berkeley Lab, or Lawrence Berkeley National Lab, is somewhat unique, and I point this out. I realize that UC Berkeley is not part of the CVT, but the point is that Berkeley Lab has a very academic culture, and in large part it is because of the co-location of the lab and the national and the university, and so we don't do any classified work at Berkeley Lab. And so for those of you that are concerned about your publications being limited, you can come to work with us, and you won't do classified work, you won't publish classified work. You'll do open work and publish that. So I'll just very quickly mention, I think I've got 4 slides directed at 4 thrust areas where we have ongoing work with DNN R&D. And so the first one I think already was mentioned today. We work with Livermore on the Freya Code, and we've also done a fair amount of work on delayed gamma non-destructive analysis of spent fuel. So both of which are kind of directly related to thrust area 2. In thrust area 3, we heard about the Coplanar Grid cad-zinc telluride detectors, which were invented at Lawrence Berkeley Lab. And so for addressing those noise issues, if you want to talk to some of the world's experts in dealing with noise issues, we'd be happy to work with you on some of that. So right now, we had built the, do I have a laser pointer? I guess I got 2, I got a mouse?
Yes, the mouse.
Yeah, all right. So we had built a 96 detector array that was called the high efficiency multi-modality imager, that is at some level a counterpart to or complement to the Polaris technology. And we're now in the process of taking that from 2 planes with a coated aperture mask in front and a solid plane in back. So this top plane is a coated aperture mask of sorts. And now we're building it into a spherical array of detectors so that we now have 4 pi sensitivity toward gamma rays in all directions. And we can do both Compton imaging and coated aperture imaging efficiently in 4 pi. That was originally that concept. So DNDO funded the HEMI project. The concept of taking it to a sphere was originally funded by DNN R&D, and now DITRA is picking it up, and we're moving forward with that. In thrust area 4, I didn't actually do anything today. Thrust area 5, sorry. We're developing a laser plasma accelerator based MonoEnergetic photon source technology that could be used. So I know the technique that MIT is studying here uses a Bremsstrahlung source, but you could use a MonoEnergetic photon source, a quasi-MonoEnergetic, to do in many ways even more sophisticated versions of that technique. So we've been developing that for a number of years and are in the 2nd year of a 5-year cycle on that project. So while we're not going to, we won't build anything that looks like this. This is ultimately the target, is to have a relatively small source capable of radiographing kind of cargo scale objects. Oops, still down. Complementary to that particular project, we have we're starting the 2nd year of a 2-year project to look at the impact of monoenergetic photon sources on non-proliferation applications. So in the first year, we looked across the non-proliferation space at all possible, or what we hope was all possible applications where it might be beneficial to have a monoenergetic photon source. It would improve your ability to do radiography, to do active interrogation, photofission type active interrogation, or to do nuclear resonance fluorescence types measurements. Dave Chichester and INL, along with PNNL and Livermore, are working on that project. So in the next year, we'll be assessing 4 different application areas, and one of those is in the treaty verification area, and PNNL will actually be leading that part of the project. And so that's obviously quite applicable. So I'll take my last minute and a half to put a plug in for SORMA West 2016, which will be held May 22nd to 26th next year, and would be an outstanding venue, particularly for students to both present and to learn a lot about the applications. We're going to take a little bit different approach this year and focus the conference a lot more on some of the advanced technology demonstrations that have gone on in the last 10 years between a lot of them from the Domestic Nuclear Detection Office, but also some from DTRA. We'll have a little bit on DARPA Sigma, hopefully, as well as some DNN R&D campaigns, hopefully, too. And so we'll have it on campus. That's at the Clark Kerr campus, part of UC Berkeley, which was just off the screen in my previous slide. So this is a self-contained campus. It has dorm rooms, and so you'll have the opportunity to stay in a dorm room, which I'm sure all of you long to do again. And we have a Harry Potter dining hall here that most of the meals will be served in. And actually, it should be a very tight venue. I think it'll be a lot of good interactions between colleagues and students, and should be a good time. So the abstracts submission for abstracts should be opening in the near future, and we hope to see you there in May. Thanks.
So in terms of what we've been up to this year, we've focused on proof of principle ideas of how we use nuclear fuel cycle simulation to support the CVT mission.